Hello everyone. Okay, so today we are going to do a live discussion on what factors to keep in mind while selecting a board for wearable design. I am Nidhi Agrawal, a technology journalist from EFI. We have today with us Mr. S.C. Devedi and Ashwini Kumar Sinha. Let me introduce them to you. Mr. S.C. Devedi is an electronics engineer and circuit designer at EFI. He has tested more than 1,000 projects and also designed more than 25 projects on various topics. He also takes live sessions at EFI every month. And Mr. Ashwini Kumar Sinha is an engineer at EFI and he holds two records on designing the smallest phone and laptops. So let us begin with the session. So my first question is related to the wearable designs only. So my first question is, what are the development boards that are good for making wearable designs? So option you share.
Sorry, there are various projects. Development boards are available in the market. One is an Indus board Quant, which is developed at EFY from the Mr. Aswani Kumar Sinha, and it is a very beautiful project for developing wearable appliances, devices, which is useful for the diagnostic, etc., medical field like that. Another board is Arduino model. Next board is Seed XIO, and next board is Adrock Flora, Spudo, Particle Argon board, Boron, Xenon, like that, and the other board is Microbit. There are so many boards are available in the market. You can use any one.
Okay. So how do you add sensors and displays to such boards?
For adding sensor and screens to the variable boards involve several steps, including selecting compatible components, connecting them to the board, and writing codes, etc. So, first of all, you have to select the which sensor you are going to use. Means selecting sensor and the screens. Second one is connecting the component. Third is writing the code according to your screen display screen. You have to write the code. Without writing the code you cannot interface. And another is integrating and enclosure design. These are the various factors which you have to keep in your mind during the selection of the sensors.
Okay. But on adding sensors and displays, the size of the device increases. So how do you maintain the trade-off between the size of the device and sensors added to the wearable devices?
Yeah, this is a nice question, and as we have already told that there are lots of as Suresh sir have already told have that there are lots of development boards are already there in the market for the variable designs like the Seed XIO and RP2040 and many other similar boards based on ESP chips or RPI2040 chips or any other chips. But when you add the displays to those displays and sensor to the board the size of the overall design will increase because if you need any gyro sensor, suppose that. So I have a board of this size, suppose that I have a board of this size. Now I add another module over above it, so overall the overall size will be increased. So the overall design will not looks like the variable, and the design efficiency is also design the whole design efficiency and power consumption also will be not much efficient because of the when we use the modular based design. So here in the Indus board what we have done is that we have included already the few sensors that most of the people use. Like if you need a gyro sensor, most of the variable device needs a gyro sensor or accelerometer sensors. that using which they can detect the direct movement, or you can fault or the fault detection, or orientation of the screen, or displays on the watch. And the another sensors they might need is the temperature sensors. So we have already included those sensor in the board, so so that overall size of your design will be not increase when you need to add extra sensors, because most of the sensor already packed in this 3 centimeter coin size of board. But if you use any kind of other board like CDXIO and RP2040, then you need to use the sensor modules above that, and the overall size of the design will increase. So it's on you how you optimize your the size. It's on you how you select the sensors on those boards. And but you still have the options on selecting the board that have already integrated sensors in the same size, or selecting the board that have not sensors integrated in it, and later you add it in the modular form. So it's up to you, it's up to the design engineers.
Okay. So that is great that it comes with a lot of sensors, but still, what are the challenges of integrating sensors into the wearable design? If you have to integrate some sensors, then what will be the challenges?
Yeah, the few challenges when you integrate any kind of sensors, the few challenges first is the compatibility with the boards and availability of the libraries. Like if I want to add any kind of humidity sensor, suppose that I want to use BMP 280 or BME 320, something like some humidity sensor to my designs. Then the first challenge is is there in library available or not, for so that I can use in my design and code according to that. And second, and is that sensor is compatible with the peripherals that is already available in the board. Suppose that my sensor work on UART, and my board don't have the UART peripheral, so of course I can't use that sensor on that. So the peripheral things and the availability of the library is the second aspect. And the third aspect is the power consumptions. If any kind of variable device, and even any kind of other device, you first thing you need to think about the efficiency, the power consumption, how much power it will consume. So when you use any kind of modular based design, when you add the modules to it, then that modules have its own voltage regulators to make it compatible with your board. So when there are multiple of voltage regulators and the multiple of modules, the voltage drop will happen at every module, so the overall power efficiency will also decrease. So when you use when so it's another level of design challenges that might you face. So you need to think about it at the very start level. So what kind of board you need to select, so that so that the sensors that you need in your projects, the design size that you need in your projects, you have to think at very initial size, and you have to select the board accordingly. And third challenge is the peripheral availability of peripherals. Suppose that if you are using any kind of displays to the to these boards for showing the sensor data, or showing the time, or any kind of user interface, then most of the display came in the SPI, and SPI displays often need 8 to 9 pins. And when you look at the RB2040 board, Exceed XIO board, and any other similar kind of board, then you have very limited peripheral, you have very limited GPIOs, like 5 to 10 GPIOs. So if you add a display and actuator, then all the GPIOs will be finished, and you can't add any more sensors and actuators to that. So you have to select the board at very initial level wisely, so that give you that much of peripheral in that small size. And like this in the Indus board, it have around 40 plus GPIOs. So you have you can add multiples of multiples of displays and sensors to it easily without thinking about those peripherals. So it's all start with the selecting of the board at the initial stage. What's your design needs, according to your design needs and availability in the market.
So as you talked about GPIO, so when you talk about some small boards, they have limited GPIOs. So how can we tackle this situation while designing wearable devices?
Yeah, while suppose that any boards like seedxio or rp2040 that have limited of number of gpi, if you choose the smaller size of board of those or any other similar boards, then if they have a low number of GPIOs, then you have to select the sensors wisely and displays wisely so that they don't use that much of GPIO in your design. Suppose that I am going to design a smartwatch that have a display and have few sensors, that accelerometer, gyrometer, or health tracking sensors. So all those sensors need GPIOs, and this displays also need GPIO. So if I use the SPI display and those analog or other SPI sensors, then I simply can't use in this board because they have very less number of GPIO. But when you choose the Indus board or any similar board that gives you the large number of peripherals, like I have already told you earlier, that at the initial stage you have to choose the board wisely, because once you have bought the board and then you need extra number of peripheral, then you will be in a very in very large problem, because that board don't have much for peripheral to add extra sensors. So you have to choose it at very initial level. So boards like Indus board or any other similar boards that have large number of peripherals, and that gives you the flexibility of adding the different kind of peripherals, like these kind of boards have the canvas, the URT number, multiple number of URT, the multiple number of SPI, and many other similar peripherals, and there are lots of GPIO already there in the board. So you not need to think about when you use such kind of board for the design. And if suppose that if you are still using those smaller boards that have less number of GPIO, then you have to select the components wisely that you are going to add. Like if you are choosing the display to for those kind of board, then you might use the display that use 2 to 3 wires, like I2C based OLED displays and something like that. And we have one question from Rakesh. Can we use the GPIO expander to handle multiple sensors and peripherals, right? Yeah, suppose that you are using XIO boards or RP2040 board or similar boards, then you have an option to use the GPIO expander to expand the number of GPIO. But again, we are talking about the wearable device, we are talking about the wearable design. So when you add an external GPIO expander to the design, then it's again came in the modular format, modular format like this. So if I add this to my design, again my overall the design size will be increased. And second challenge you will face with the GPIO expander, that the GPIO expander actually need a GPIO to get address and to control a GPIO, that it gives you the expansion. So that GPIO expander itself needs some GPIO, and it need to be communicated either by the SPI, URT, or I2C. So in any case, you have to tell that GPIO expander to turn these digital inputs outputs, or or how to use this digital inputs output that is given by the that expander. But when you do this, there is a delay in the code. There will you will face the delay in the code, because you need to write the code and tell that expander what to use that GPIO. So the code, the flow of code will be delayed, and overall processing will be also got delayed. So of course you need the GPI expander, like Rakesh have told, but it's increase the overall size of the design, and also the the processing will be delayed in such kind of scenario.
Okay. So you were talking about displays. So how can displays be integrated with these boards?
Yeah, again repeat the question, please.
How can displays be integrated with these boards?
For integrating the sensors into the variable design comes with the several challenges. First of all, size and form of factors, and second, power consumption is also keep in the mind. Data accuracy and reliability, interference and noise, data fusion and factors, user acceptance and usability, and the cost is also to be considered. These are the very important factors because when you are designing a project, if cost is very high, then it is not suitable designing. So cost is also a very uh, important parameters to be considered during the integration of products.
Okay, as we have discussed about cost, so is it possible to make small devices by spending less money?
Yeah, Mr. Sinha can describe more detail about the cost, etc.
Yeah, for the cost optimization, for the cost optimization, suppose that if you are using any kind of then, and if like I have already told you earlier, it's all about the initial stage selection. What's the component you are going to select in your design? So optimization happens at the initial level as well. So suppose that I need I am going to make a design of a wearable device that need to detect the fall of any old age person and need me to notify me either while using the Wi-Fi or using the VLE. Then we have to choose the board wisely at the initial level that give me all those functions at the very lower cost. Like suppose that if you are using the Arduino Nano boards, or if you are using the RP2040 boards, or if you are using the CXIO boards or similar boards. So if those boards giving you those sensors at the initial level of at the small at the lesser cost, then you can simply choose those boards. Or like suppose that if I need such kind of design, so this Indus board gives you the gives you the sensors like gyro sensors and magnetometer sensors. So in overall bill of material, I have to remove these sensors by default, because if you add any kind of magnetometer sensors to any device, then magnetometer sensor itself cost you around 500 to 800, or sometimes the sensor module, even magnetometer sensor module like LSM 303, cost you around 900 rupees. So if you add those sensor to those boards, that comes in the 1000 of board cost, and the 1000 rupees the sensor. If you choose a modular based design, then again it's cost you lots of money. And the size of design also increases. But when you use the boards that give you the sensors, availability of sensors at the initial cost, at very low cost, integrated inside the board, then the overall size is already small, because it's already integrated in the board. And second, as the sensor is already integrated in the board, so you now need to add extra you now need to pay extra money for those sensors. And third thing is the power optimization will also happens, because like if, suppose that I am going to design a device with the board that don't have the sensor, and I choose the modules. Okay, so in the modules, that sensor have to optimize the voltage regulation and power. So that sensor module needs a PCB, and that sensor module also needs a voltage regulator. That sensor module also needs a capacitor and some other discrete components. So all those bill of material cost get included with those with your design. But if those things is already integrated in the board, then the PCB of that you are the PCB cost that you are paying for that extra module, it's get removed, because it's already there on your present on the board. And second, the components like voltage regulator, then one single voltage regulator can handle the both the processing power of the board, main chip, and the sensors. Then the regulators, multiple need of voltage regulator at the modular design will also be decreased, and the discrete components will be also decreased. So if so you have to think about this at the very initial level, what kind of board that is giving you all those facility at the very initial level, so that you later do not need to spend the money on those extra modules, or buying all those extra displays and all those things, or GPI expanders, all those extra modules. So it's a start at the very initial level, what you choose.
Okay, okay. So, as you talked about power consumption, so how does the board let you control power use?
Yeah, for the case of this Indus port, it gives you the flexibility of on controlling the power at the various levels. Like it gives you the power consumption, first power control level at the connectivity level. Suppose that if you are using the Wi-Fi, then it gives you the flexibility to control the Wi-Fi. Like you can turn on the Wi-Fi, turn off the Wi-Fi programmatically. And it's also give you the flexibility to control the consumption of the Wi-Fi power. So you can control the how much power it will consume when it is in TX mode, the transmitting data mode, or it is in RX mode, receiving data mode, like it, or acting as a Wi-Fi. So you can control all those power consumptions using the code. You can turn on the Wi-Fi, you can turn off the Wi-Fi timely to conserve the power. And you can even set the power limit, that this is the amount of power limit that board should use while transmitting the data and transmitting. Of course, the range will be compromised when you use this technique. So this is the first level. And the second level is the chip level. On the chip level, these kind of boards gives you the flexibility of the baking the chip or making the chip on deep sleep. Like there are various kind of sleeps in this board. So first one is simple sleep, second one is the deep sleep. So on the simple sleep, you can make the sleep, you can make the device sleep for the shorter period, or simple, normal period. And also accessing some a smaller processing at the same time. And you can also use the deep sleep. So on the simple sleep, the whole chip use only 20 microamps for this kind of boards. For the deep sleep, it's around 16 milliamps for the deep sleep. So it depends. And the third level, it gives you the flexibility on the processing power. So if you suppose it's this boards, you can select the different level of processing power for this board. Like the clock frequency, like 240 megahertz, 280 megahertz, 65 megahertz, and certain megahertz. So you can choose that. It's on you. You can choose it programmatically. So suppose that if you don't need what 240 megahertz of clock speed, then you can decrease the clock speed to the 80 megahertz, and it will only consumes the main chip only consumes around 12 milliamps only. See, this 12 milliamps only. So you can it gives you flexibility at the level of the processing power as well. And the third is the co-processor thing. These boards and the similar boards like this have the co-processor on it, like ultra low power co-processor, and these boards have the two ultra low power co-processor. So even if your main chip is in sleep, you can still use simple small processing, like taking small amount of sensor data on I2C, or checking the interrupts of the sensor using the ultra low power co-processor that's using only 20 to 30 microamps, not milliamps. It's a microamps. So there is a huge power conservation at this level. So suppose that you are making a smart meter for a city that need to gives you the meter reading once in a month. You not need to read the meter reading the whole month all the times. That need to send the meter reading once in a month to the municipality. So in such case of scenario, you can make the main chip sleep for that 1 month, whole 1 month, and then wait for few seconds, and it will connect to the Wi-Fi and check the meter reading and send to the cloud, and again go into the sleep. So here the whole month chip is in sleep, and it only wake for a few seconds in the month. So here the whole month is chip in deep sleep, consuming only 20 to 30 milliamps. Then it consumes lots of battery power in it. Someone have I have even read someone have claimed that if you put this ESP chip with the 3 volt coin cell with the deep sleep, it will work for 5 years. So on the 3 volt coin cell on the deep sleep, this chip will work for the 5 years. So there are lots of power consumption here. And the third level of power consumption is at the sensor level. Like if you use any kind of boards like RP2040 or any other boards are already there in the market, and you are using the modules, adding the modules for the sensors. then the sensors are always actively on and consuming the powers, and the light on the sensor module also consuming power continuously. But the sensors, the gyro sensor, accelerometer sensor, temperature sensor on this board have very low amount of power consumption, and that can be even put into the sleep as well. So you can also turn off the sensor, you can put the sensor in the deep sleep as well, and the whole sensor do not consumes more than 20 milliamps. So it's very less amount for any kind of sensor module that you find in the market. And for the sleeps, you can this board you can put this board on the wake up and sleep on the time basis using the RTC. So using the RTC, you can put the sleep chip, this whole board sleep for the 1 year, 2 year, or once in a month. It's on you. So it gives you the flexibility at the various design stages, and you can control the power at every stage programmatically. So that's my answer.
Okay. So, talking about the power consumption. So, when you compare this in the sports point board and Arduino Uno, which one have more power consumption?
So like if you're using the boards like or any other similar boards, then they use lots of powers at the initial level, because they don't give you the flexibility of putting those chips in the deep sleep, and they have lots of indicator lights and all those things. But these boards have the programmable lights for the indication. So if you want to put those lights on and off, then you can save the power from that as well. And those boards are good for the prototyping and making school projects. But if you want to make something like wearable or miniature electronics design, where you need the power efficiency and also the without compromising the connectivity and the and the uh, processing power, then you can consider these boards like Indus board Quine or RP2040 board or something similar, like similar something like similar boards.
Okay, okay. So we have one more question from Rakesh, and he's asking that how many layers in PCB is recommended for designing a miniature device where MCU is EMC32, and what will be the minimum track width for such devices?
Yeah, that's a nice question. That is Rakesh. Why Rakesh? Rakesh. So minimum layers, it's depends. It again depends on your design. How complex your design is. If your design using very less number of components, very a small number of components, then single layer is enough for that, because it saves you the PCB cost, PCB manufacturing cost, and also and I think single layer is enough for most of the designs using these kind of boards, Indus board, because you can simply put the Indus board here, and any kind of a small chips or sensor here or above it, and then make a single layer design that connects the GPIOs. So for GPIOs connection, you just need a GPIO connection. So you need single layer is enough. Single layer is enough, I think. But if you have a lots of sensor, lots of display, like you have more than 10 displays, more than 10 sensors, then of course, and you need a compact design, then again you need the multiple layers. But for a small number of sensors, one layer is enough.
Okay, great. So let's getting back to the power consumption. So as you told us that in this board is using less power and Arduino knows more. So are there any ICs in the market that help reduce power consumption?
Mm.
Yeah, there are several types of ICs are available in the market to reduce the power consumption of the electronic devices, such as first voltage regulator. There are various types of voltage regulator available in the market. Few voltage regulator has more power and another package. Few are the less power and the same another package. For example, if you are using regulator 7805, what its TO22 package is carrying 1 ampere current, while It's the same regulator. TO92 package consumes 100 milliampere. So it is very important to reduce the IC. IC itself package depends on the reduction of the power. When you use minimum current carrying package, then power will surely reduce. So first is voltage regulator, and similarly battery management ICs, BMICs are also useful for reducing the uh, current. And another is power management ICs, PMICs, and it also reduces the power. Another is DC to DC converter are used to convert the one DC voltage into the another high efficiency voltage. So DC to DC converter is also very useful. Low power microcontrollers are also used. Low power MCUs are also used. Another is low power sensor. When you are designing the project, use the low power current carrying sensor. So it is also very useful parameters. Another is energy harvesting ICs. Energy harvesting ICs are also used to capture the stored energy from ambient sources such as solar, thermal management like this. It can also be useful. And one last one is RF transceivers and low power modes. Using this mode, you can also reduce the power.
Okay. How do you use a clock to wake up and sleep on the board without using too much space or money?
Can you repeat the question?
Yeah, yeah. So, how do you use a clock to wake up and sleep on the board without using too much space or money?
Yeah, so suppose that if you are using the boards like this Indus boards, like this Indus board, or any other, another board for the variable design, then and for the power for saving the power, you might use the time based sleep and wake up to save the power. So when you use the time based sleep and wake up the chip, then you often need the RTC for such purpose. So if you're using the Adreno Nano or any similar Adreno board, then the RTC based power sleep and wake up is simply not possible. If you're any another board, then you also need the RTC modules. And when you add the RTC modules for such designs, for a small design, then again it's increase the size of the board, because I am using suppose that this board, and I also adding the uh, RTC module. So the overall design size will be increased if I add the external RTC module. But if you're using the boards like the Indus boards, like these boards, so you don't it already have the RTC module built in. It counts the times using the crystal oscillator that is integrated inside the chip. So it have already built in RTC function inside the chip. So you not need to worry about buying the extra RTC module and adding to the design, and then baking up the chip on the time based, or doing the processing on based on the time, or keeping track of the time, because these kind of Indusport coin have already built in RTC modules as well. So that is another good function of these kind of Indusport, that you not need to add extra modules like RTC to keep track of the time. It will do it by itself. And this RTC module can even work when the main chip is in the sleep. Suppose that you as I've already told you that you can put the main chip on the sleep, and it have ultra low power co-processor that only consumes around 20 microamps to 30 microamps based on your processing power. So you can put the main chip on the sleep, and you can use the RTC on 20 microamps to calculate the time and bake the chip on the particular interval of time, and then do the processing. So this is how you can save the overall design size, overall the cost of the BOM, by already getting the RTC function inside this tiny little coin, and also save the power.
Okay, and so in this whole RTC is already inbuilt, but when you add RTC to a design, then bill of material increases and also the module size increases. So how to tackle such situations, such design challenges when you're not using a board which is having already RTC inbuilt?
Yeah, so when you, if you're not using the boards like this Indus board, and you choose to use the any other another boards that don't have the RTC chip built in, then you of course you need to add extra RTC module and the battery as well to add for the RTC, because when you put the main chip on the slip, that chip is using the battery, and suppose that battery got drained by the thing, then RTC module it needs a separate battery for its backup in such case of scenario. So it's a very challenging, but to fix this challenge I suggest you to use the RTC modules, choose the RTC module that are smaller in size and that do not consume much power. And another way is of doing that is using the clock to calculate the time, but internal clock speed, uh, uh, but uh, but that maybe not much accurate, like there might be, you might we get variations about 1 minute to a minute after long interval time, because some of the clocks might be, not be calculated by the device. So it will be challenging, but you can do by these kind of tricks. And I have one more question here from some Rakesh, our IoT R&D. I was not aware of energy harvesting. I see. uh, okay, so there are various kind of energy harvesting ICs there in the market that harvest the energy for use for low power consumption device. Even the batteryless designs. Like I have designed recently the batteryless display using this Indus board. So there are various ICs there in the market that harvest the energy, and those energies are in the form of movement, of vibrations, or the RF energy, mostly the RF energy. So few of the ICs is the LTC from the Sparkfun or something like that. 1 minute, let me check. Yeah. The module name is LTC 3588. Is it is the energy harvesting module that will get easily in the market. There are various companies who are manufacturing this LTC 3588. So you can add the solar panel on that module, and or you can add any kind of another coil based energy harvesting thing on that module, and it will harvest the energy, and at the other end you can directly power the board using that, if it is harvesting enough power, or you can charge the battery using that. Is it possible to harvest 5G waveforms? Yeah, of course. That's a good question, and that's a good idea. In fact, I am trying to work on that. So actually in the 5G spectrum there are lots of radiation, and these radiation are actually the energy, the whole lot amount of energy in the environment in the 5G. So if you have a lots of tower around you, 5G towers around you, so a lots of energy are there radiating from those towers, and you can easily harvest those energy. Like I have already told you, you can use the LTC 3588 IC. So using that LTC 3588 IC, and you can add a energy harvesting coil that harvest that consumes those electromagnetic energies, and then convert that into the electrical energy, and charge the supercapacitor. You can either add the supercapacitor, or you can add what's a battery to charge it, and you can use that power as well. Is it legal to harvest those energy for the commercial product? Yeah, I think it is legal, because most of the company are using these kind of energy harvesting. Even recently in the electronics, for if you check the electronics for you truly innovative section, we have just selected lots of innovative components that works without the battery. Can you believe that? Those chips work without battery for the year. Those are the IoT modules, and these are industrial modules that is working without any battery for the years, and they're all using the same technique, harvesting energy. So what these modules do, these modules do harvest the energy from the environment, RF energy, heat energy, and other ambient energy, convert them into the usable form of energy, electrical energy, and then power the device. Those are small, that is required very those chips require very small amount of power. They are usually NFC or BLE based, and the whole device run without even battery. You can check the EFI, a truly innovative sections for those devices. Like one of the there is one microcontroller I remember that works without any kind of battery. Can you believe the whole microcontroller works without battery? It do the processing, it do the IoT thing, it transfer the data without any battery. And you can check the electronics for you truly innovative section. The chip name is Oni 100 or something like that, the chip name is. And there are lots of other modules are there in the truly innovative section. So you can always check the electronics for you truly innovative section. We always select the one of the best components that change your design problem and change the way you design. So if you check that section regularly basis, then you will get lots of design idea using that. So we have a lots of sensors, modules, and energy harvesting IC. The PMIC, there is one of the PMIC from the EPG that we have selected for the true limit section of the electronics for you, that gives you the energy harvesting using the BLE and Wi-Fi, and it will harvest the energy from those BLE and Wi-Fi networks and powers the chips and consumes lots of power, even the 50% of power. So you can check that out. The chip is from the EPG company. So there are lots of companies are there that are harvesting the power and it's legal because lots of industrial sensors are there, and you can check all those sensors and list of those energy harvesting ICs and chip on the electronics for you to innovative section. And of course for this Indus board you can also use the LTC 3588 with this Indus board to power this device with the battery and harvest the energy and make the energy harvesting projects or very low power consumable projects. And recently I have made the battery that harvests the electromagnetic energy batteryless display using the e-ink, and it will be published soon. So of course you can use the energy harvesting things. Each
Could you please suggest which solar panel is best for small projects?
Yeah, could you please suggest the best solar panel for the small projects? Asked by Sanmitra.
Mitra.
Yeah, Sanmitra. So thank you for the question. This is really a good question. So it depends on your power consumption use. How much powers do you need in your design? Suppose that if you are using what say if your project using only around 2 to 3 volt of power voltage and around 100 to 100 to 180 milliamps, then you can easily use a small circular solar panel that is available in the market, and there are lots of similar solar panel are there available in the market. You can check them out. So you can easily use for those. So it's depend on your design, how much current your design need, how much power your design need. And do the whole project can be powered with the solar panel itself by harvesting the solar energy, or do you need extra battery that charge up the battery and saves the battery lives and cycle, and use the solar power when solar is available, and then power it using the battery if the less amount of power is available for the solar cell. So it's on your design need.
Okay, so next question is from Rakeshi. Do we need any special certifications for the harvesting?
Uh, I don't think so. For the prototyping and designing, I don't think so. You need. I'm not very surely say that, but I don't think so. You need any kind of certification. I have itself. I might say I am one of the person who have worked on energy harvesting projects a lot, and I have. In fact, if you check the EFY issue, DIY issue, there are various projects I have published on energy harvesting. One I'm talking about the batteryless display, that display run without any battery. Without any battery, it will run totally on by harvesting the power. And one of the project I have done is the using LTC 3588 module is the is the batteryless remote. So I have designed a remote that work for years without need of any battery. See, your TV remote need no battery. So what it does, it have the solar panel, it have the piezoelectric, it have the movement membrane that convert the movement into the electrical energy and harvest all those power and power the remote. So you can check the electronics for you issue, and you can also search on electronics for you batteryless remote, or you can search on the Google batteryless remote EFI. You will get that projects, energy harvesting projects. So I myself have designed many kind of energy harvesting projects and devices, and do R&D on energy harvesting modules and chips a lot. So for me, I don't need any certifications. This is my personal this is my personal view. But from your side, you might need it. But I don't need any certification. I don't even have electronics electronics degree, engineering degree. But yeah, it's on you. And for the if you're asking regarding the device user certification, commercial use certification, and license, then it depends on the area where you are using it. Like yeah, so I have one more question from Rakesh. IoT R&D, I am targeting for a commercial use of my product. That's why I want to make clear any license. Yeah, if you are using the commercial, and suppose that if you are using that commercial project, that energy harvesting product for the industrial purpose, IIoT, or for the wearable things, then for the wearable things you need the license. For the industrial thing also need the license, so that you have to certify that this license actually check whether this device will able to sustain in those industrial environment or not. Do it hazardous for those industrial environment. So these you have to take care of these things while designing your if you're using for the if you're designing for the industrial purpose. So at the initial level, you have to take care of the design, that your design will withstand with the temperature range and the environment condition of industrial. If you are using it for the consumer in consumer products, suppose they're wearable health devices or something, then you have to make sure that device is not going to harm the people skin, or people day to day life, or it is not harming any health issue to the or environment issue to the person. So for industrial and the wearable thing, if it is used by the human, then of course you need some kind of certification. And the second level of certification need is the if you are using that device, if you are trying to sell that device in the Europe and the United States market. Like if I want to launch this indus board for the Europe and the United States markets, then I need a European Union CE certification and FCC certification. If you are using the RF energy, like the Wi-Fi, BLE, Zigbee, or any other kind of energy, then you need those FCC and CE certifications as well. So it's depend on the region as well. What are the policies in their country, so one of the solution that like I have designed this Indus board, and I want to launch it in the US and European market. So the certification is needed. So at the initial level, what the precaution I have taken, that you can choose the module that is already been certified with the CE and EC, C certification and FCC certification. Like I have designed this board with the module rather than the chip with C and FCC certification. So it is likely very high chance that it will pass the certification process later if I apply for the certification. So you have to choose the module that is already pre-certified, and you have to choose the sensors at the initial level, or components at the initial level that is pre-certified, and that fits for those conditions for the licensing. So it's a start at the very initial level. That I have already told you that at the design, you have to think everything at the initial level. What the function you are using, for whom you are designing, where you are going to deploy, what are the environmental condition you are using it, you are designing for. You have to think all these things, simple steps at the very initial level. Because once you invest in the component, and later you find that this component didn't pass the FCC certification of C certification, it is even some kind of radiation, then you have to restart your design process from again. So it's better to do it at the very initial level.
Okay,
uh,
we have one more question from Rakesh ji. For Tier 1 city, I'm targeting domestic market to use energy harvesting things. Where can I get more information on this? Any reference inside India?
yeah, it's again asked by Rakesh. For tier
Rakesh.
1 city, I am targeting domestic market to use energy harvesting thing. Where we can get more information on this? Any reference inside India? I am not sure about it, because but I will take this question. I will answer it later, and might be I will publish on in my article later on this energy harvesting certification and something. I'll answer you there. I am not sure about it. I have to do research on this for your question. Uh, right now, I am not sure regarding these things.
Okay, so let's get back to the very nice questions, and you answered them very nicely. So let's get back. We were talking about battery life optimization. So what strategies can be used to optimize battery life in wearable designs?
Yeah, for the battery life optimization there are various process, like for the case of, suppose that I am going to tell you about the Indusport case, and later I will ask my colleague Suresh Dwivedi to add his words as well for the other design. So let me finish my part. So for the Indusport side, if you want to save the power of the battery, if you want to, can you repeat your question one more time
Yeah,
so
yeah.
that, yeah.
So what strategies can be used to optimize battery life in wearable design?
Yeah, so a strategy are at the various level. So suppose that your design do not need any kind of indication, like LED indication and some other kind of similar indication. Then you can put those LED, you can minimize the use of those LED indication, or simply remove those LEDs in the design, because those LEDs always blinking and doing those stuffs for the, so they consumes power. And second thing, suppose that you are designing a smartwatch, or like here I have designed a smartwatch that show me the time, speed, and another thing using the Indus board. So if you're designing a smartwatch, so if the display is always on, or display backlight is always on, then it's always consuming the power. So what you can do is you can programmatically set the on off system for the display lights, by making the display into go into turning off the display light, or turning off the display. Or suppose that if you are using the IoT things like Wi-Fi, if you are using the Wi-Fi or BLE, suppose that like I have said, suppose that you are designing a device that like a smart water meter, so it need to uh, gives you the how much water used by you once in a day, or once in a month, or once in an hour. Then you not need to keep the device on for all those long interval of time. You can simply turn on the Wi-Fi, and the chip process the data and send it, and then turn off. So this is how you can save the power. So you can do these all these things from programmatically. Suppose that I have designed the smartwatch with this display and with the Indus board. So suppose that it is transmitting me the GPS location and showing the speed and all those things on the watch. So whenever I need, I can simply tap and see the details of all those details. And after 5 seconds, I simply make the whole things in the deep sleep, so that it consumes the power, conserves the power. So at these levels of making the chip sleep, bake on the time intervals, or turning off the light indication, turning on the light indication, and using the energy harvesting modules. So using these kind of similar smaller step in your design, you can save the overall power consumption of the device design. And power consumption very important for the wearable device, because the wearable device size are very small. And if the more the battery consumption the wearable device need, the more uh, 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 the more it give it takes you the flexibility from adding the function and components to the device. So if you keep the right balance between the power consumption and the functionalities, then you can make a very smart devices and power efficient devices. And we have one more
Okay.
question. Should we prefer Node MCU and STM for no voice circuit? I can't really understand your question. Can you describe the question again? Yeah.
Okay.
Over to Suresh Dwivedi ji. If you want to add any more words to it, how we can save the battery power and power consumption.
Power consumption is totally based on the application. Suppose you are using so many output like LEDs, etc., etc., then you need to add more powerful ICs, etc. And depending on the package, example, suppose any IC, say any regulator, it founds in so many packages. Some package have carry more current and some few packages are carrying very less current. So it depends on the project you are making. If you are making so many output, then you have to take more carrying current component. If you are using very few outputs, then very you can use a small carrying current and package. SMD packages are used mostly for the low currents. So not need of using deep or any other package, but using a small current consumption means using very few outputs. Then you need very small current carrying SMD like that. And this is the very important for the reducing the current.
Okay, great. So, I have a last question from my end that what are the most common sensors used recommended for miniature wearable designs? I'm repeating. What are the most common sensors are recommended for miniature wearable designs?
Yeah, well, this depends on the design needs of the designer. But most of the common sensors that for the miniature design often need is the gyro sensor, the magnetometer sensors, sometimes the GPS, and sometimes you also need the modules Wi-Fi or BLE modules, and sometimes you also need health tracking sensors. So there are various sensors for all those. Suppose that if you need a gyro sensors or accelerometer sensor, IOMU sensors, then there are lots of sensors from ST uh, and XP are available. Like from ST side, LISM MDL and LSM 303 are available. That gives you most of the sensor need, like gyro sensors and the magnetometer sensor need fulfill the need in the smaller package. And there are for the health tracking, there are sensors like max 30100 or max 30102 are there that gives you the tracking of the health data like heartbeat, your temperature, body temperature, and the blood oxygen level. So and for the movement tracking and for the the location tracking thing, there are lots of GPS modules are there available for the wearable device. So if you for the wearable device, if you're designing the wearable device or miniature device, the size matters a lot. You need a smaller modules for those. So for the GPS, you can use one of the GPS module like this. This is a small GPS module. So I am working on the projects with the in this Indus board, making world smallest GPS tracking device. So I can use this kind of a small GPS module with this board and add it to make a small GPS tracking device that can fit in your watch or as a keyring. So you can these kind of a smaller GPS modules and boards for the wearable design. And
Okay,
second, we
so
have, yeah,
mhm,
yeah,
continue.
yeah. And let me take one few question from the from the audience side, if you allow me, if you have
Mhm.
the time. So one of the question is, should we prefer Node MCU and STM32 for as a newbie
As a
circuit,
new circuit designer.
as a newbie circuit designer? So if you're I think STM32 is also good, and Node MCU is also good. It depends on you what you want to use as a newbie designer. both are compatible with some, but STM32 is little bit not compatible with some version of STM32 might not compatible with Arduino ID, but Bluepill is one of the development board that is compatible with Arduino ID, and you can easily program it in the Arduino ID. And for Node MCU, there are, yeah, it is also compatible with Arduino ID, so you can use those as well, or you can also use this Indus board, because this Indus board have the pre-built sensors, pre-built gyro sensors and many other sensors, and it have lots of good projects examples that gives you a lots of learning. And its size is also small, so you can design and think many kind of projects, and it also gives you the flexibility over the IOs. Like suppose that if you're using the STM32 or any node MCU, then if you want to add URT device, or if you add SPI displays and devices, then the pins are predefined. You can't change the pin if you want to use any other pin for the connection, but it gives you the flexibility. All those, if you define in the code these are the pins for the SPI, it will take that pins as the SPI. If you don't define, it will use the default pin. So and it gives you the all those things in the small size as well. And you now need to add and connect extra sensors, because as a newbie, if you need to add extra sensors, then it will be very tough for the soldering job and connection on the breadboard, but sometimes connection code break. So if most of the sensors are already there in the board, so you can also prefer. And these boards it compatible with the Arduino ID as well, Python, MicroPython, and Scratch as well. So it's you can program it in a multiple platform. You can learn multiple of programming language with a single boards. So you can also use this kind of board as well. So it's on you. You can prefer Indus board Quine or Node MCU, whatever you think uh, for the design. As a new circuit designer, which port we should prefer for designing the circuit? Yeah, this is the same question that we have. So
Exactly.
I think I've already answered. Uh, I suggest you the Node MCU ESP based board, or this kind of Indus board that gives you all the sensors pre-built inside it, and the flexibility with the GPIO, and many example support and personal help support for the design challenges and learning. Because these boards are compatible with multiple of programming language like Arduino ID, MicroPython, and you can also program it in ESP, IDF, and many other things. What about the Raspberry Pi? Yeah, Raspberry Pi is for the little bit of high-end design. Raspberry, we are talking about the wearable electronics design and microelectronics design. Raspberry Pi size is little bit big, that fit for the wearable design. But yeah, Raspberry Pi, you can use the Raspberry Pi for the design where you need high amount of processing power, where you need the GUI or some kind of computer like of processing power. Like Raspberry Pi give you the GUI, the whole OS for the for your needs. So you use the Raspberry Pi for for high in the processing power need, and where you need much where you don't care about much power consumption, because Raspberry Pi will consume lots of power. They are not microcontroller, they are microprocessor. Embedded C, in the embedded C programming as well. Yeah, Arduino is actually based on C, so you can program it. And for the C programming language, embedded C programming language, I have to look on the Indus board how to make it compatible with the C programming language as well. But I think you can do using ESP IDF. ESP IDF, I think that is the, and platform IO, both are the based on the C language, embedded C.
Mm.
So you can program using this board using the ESP-IDF and platform IO. And there are lots of example you will find. The way you use the Node MCU, the code that works on the Node MCU will same works for this board as well. The code that you use for Arduino, the same code works for this as well. And you can also use the MicroPython. I think for the beginners, the embedded C is little bit complex. MicroPython is a good choice because it is easy, and a lots of libraries are also used. And then second is the Arduino ID, because you get a lots of pre-built example and libraries for that. So any more question from your side, you can ask. I am asking for the the audience, if any of more doubt and question, then you can ask.
Okay,
So
so I think they can also post questions and we can reply later on in the next session. So I hope the discussion was very useful to all and it was a very brainstorming session. And we got great insights on how to design variables and miniature designs using various development tools. So thank you for watching.
okay, thank you everyone.
Thank you.